Example 17. Example 17 asks us to find and classify the turning point of y is equal to 2x cubed plus 7x squared plus 4x minus 3. Alright, in order for us to find the turning point, we're going to use the fact that at the turning point, or at the stationary point, which is the turning point, dy by dx is equal to 0. By putting dy by dx is equal to 0, I can determine the value of x at the turning point. So let's first find the first derivative. Dy by dx would be equal to 6x squared plus 14x plus 4. Alright, so at stationary point, dy by dx is equal to 0. So we're going to have 6x squared plus 14x plus 4 is equal to 0. I can divide the entire equation by 2. I'm going to have 3x squared plus 7x plus 2 is equal to 0. Alright, let's solve this equation to get the values of x. So we have 3x here, we have x here, we have 2 here, and we have 1 here, both positive. So therefore 3x plus 1 is equal to 0, or x plus 2 is equal to 0. Therefore x is equal to minus 1/3, or x is equal to minus 2 are the values of x at the turning point. In order to have the values of x at the turning point, I need to determine what are the values of y. So I know the value of x, I need to know the value of y in order to know to get the full turning point. So going back to the equation, try and save some space. I can say when x is equal to minus 1/3, right, I think that's one of the values of x, minus 1/3 and minus 2. When x is equal to minus 1/3, y would be equal to 2 minus 1/3 cube plus 7 minus 1/3 square plus 4 times minus 1/3 minus 3. So y would be equal to minus 2 over 27 plus 7 over 9 minus 4 over 3 minus 3. Alright, so y would be equal to minus 2 over 27 plus 21 over 27 minus 36 over 27 minus 81 over 27. So what we should end up with is this would be minus should be all over 27. We have 21 minus 2 minus 36 minus 81. So this would be minus something. This is 19. This is 19. 36 minus 19 is what? 17. And 36 minus 19 is minus 17, minus 17. Minus 81 would be minus 98. So this is minus 98 over 27. So I have the first turning point, which is minus 1/3 minus 98 over 27. All right, the second turning point, I'm going to say when x is equal to minus 2, y would be equal to, it is 2 times minus 2 cubed plus 7 times minus 2 square, 4 times minus 2 minus 3, plus 4 times minus 2 minus 3. So this is minus 16 plus 28 minus 8 minus 3. Alright, so this is 20 minus 16 is 4, minus 3 is 1. Let's go if it's 1. So this turning point is actually minus 2x minus 1y. So I have my two turning points. The next thing I need to do is I need to classify my turning points. Alright, so to classify my turning points, I need to look at the gradient before the turning point and the gradient after the turning point. Dy by dx was equal to what? 6x squared plus 14x plus 4. So it's 6x squared plus 14x plus 4. Alright, so looking at the first turning point where x is minus 3, I might minus 1/3, I might use when x is minus 1 to get a point before the turning point, to get the gradient before the turning point when x is equal to minus 1, dy by dx is equal to 6 minus 1 squared, 14 minus 1 plus 4. So this is 6 minus 14 plus 4. This is 10 minus 14. So this is minus 4. Minus 4. So the gradient before the turning point is negative. Let's have a look at the gradient after the stationary point. I'm going to say when x is equal to, let's say, 0, right, it's not over yet. When x is equal to 0, I can see that dy by dx would be equal to 6, 0 squared, 14 times 0 plus 4, which is equal to 4, which is positive. Alright, so it's negative, positive, so it's negative, 0, positive. So minus 1/3 minus 98 over 27 is a minimum turning point. All right. Space. Can we find any more space to finish this question? Let's see if we can. I don't think so. All right. When x is what? The next one is when x is what? Minus 2. All right. So there's no space. There's no space to solve this question. So let's go to the next page. All right. Dy by dx is equal to 6x squared plus 14x plus 4, and the next turning point that we need to classify is minus 2, minus 1. Just before minus 2 is minus 3, I could say when x is equal to minus 3, dy by dx is equal to 6 minus 3 squared plus 14 times minus 3 plus 4. So this is 6 times minus, sorry, so square, 6 times 9, which is 54, minus 14 times 3, which is I think what, 42, plus 4. So this is 58 minus 42, that would be what, 16? So 58 minus 42, so let's just say it's 16. So the gradient before x is equal to minus 2 is positive. I could say when x is equal to minus 1, which is after x is equal to minus 2. If I'm not mistaken, I think we found this already. And when we did, found this already, when x is equal to minus 1, when x is equal to minus 1, we found that we got when x is equal to minus 1, we got minus 4, minus 4. So we can go back. When x is equal to minus 1, dy by dx is equal to minus 4. So before the turning point, the gradient is positive. At the turning point, the gradient is 0. After the turning point, the gradient is what? Negative. So here I can see that minus 2, minus 1 is a maximum turning, point. All right. So there we're classifying a turning point using the first derivative.